Good. What do we call this polynomial? A quadratic trinomial. Okay. The directions are factor. What does it mean, two factor? Right as a product. Can't factor it like we learned on Tuesday. Why not? Because there's only three terms. So what did we learn on Tuesday? It's called factor by grouping, which can only be done with four terms. Okay, the greatest common factor is 1 here, so we can't factor that out. So how in the world are we going to do this? Our goal is to get a product of two linear binomial factors. This has to be x and x. Why does it have to be x and x? Yeah, because when we multiply these out, we get x squared, and we got 1x squared. Let's say it's plus. What do these two numbers have to multiply to be 12, right? So these, when we multiply these two, it has to equal to 12. So we got our x squared. So the problem is there's lots of factor pairs that equal 12. What are the factor pairs? So 1 and 12. What else? 2 and 6. What else? 3 and 4. What else? -1, -12, -2, -6, -3, and what is it? -4. Thank you. Okay, those are called factor pairs. I guess a pair of numbers that multiply 12. Factor pairs of 12. So we got 1, 2, 3, 4, 5, 6 options. So should we just guess one and multiply it out? Good. Why you say no? It takes a lot of time. How else are we gonna do it? Let's go back up here. This is the problem we're factoring. I need to figure out why it's 2 and 6. It's gonna be 2 and 6. It's gonna be x plus 6 times x plus 2. So how can we look at this and figure out it's gonna be 2 and 6? Why don't you discuss that with your neighbor? Somebody from this side of the room, tell me how do we figure out it's going to be 2 and 6? Yeah. Okay, and why do we care that it adds to 8? Yeah, because when we multiply this one and this one, okay, we get our two middle terms, and then we combine like terms to get that. Okay, so a lot of times, eventually we want to do this in our head, but until then, we can write the sum. The sums are going to be 13, 1 and 12. 2 and 6 is 12. No, 2 and 6 is 8. 7. Negative 13. What is that? Negative 8 and negative 7. Okay. And of course, the 8 is the same as this 8. So we know it is going to be these two. Okay. It is going to be this. We can then multiply it out and check. The other option is to change this to x squared. I'm going to change 8x to plus 2x plus 6x. And now, how many terms do I have? 4. And how can we factor with 4 terms? By grouping. So watch when we group. Got x times x plus 2. 6 times x plus 2. And then we have this common factor, which is right here. And then the x plus the 6 is right here. Okay. This is important later when the leading coefficient is not 1. See why later. But there it is. So let's look back at the previous examples for this. This adds to be negative 13. So the first off, if it adds to be a negative number, but they multiply to be positive, where do they both have to be? Negative. Okay. If this is positive and this is positive, they both have to be positive. We'll see later when one is negative, one's not. Okay, let's do some more. So what are we looking for? Factor pairs of what? Of negative 45. Okay, which are negative 1, positive 45. 1, negative 45. 3, negative, what, 15? Okay. And then the sum of those two numbers are 44, negative 44. Is it negative 12, 12, negative 4, and positive 4. So which one is it going to be? 5 and negative 9. Plus 5 minus 9. And that's it. We factored it. We can check. How can we check that we got it right? We multiply it out. X squared minus 9x plus 5x minus 45. Sure enough, we get that. So indeed, this is our factored. Okay. This method, what we're doing, where we list out the factored pairs of the sometimes known as the C term. I'll explain that in a minute. Only works when the leading coefficient is 1. Okay, we'll talk more about that. Okay, try to factor this by yourself. You got that? Again, let me show you if we do break it up. All right, we change this to x squared, and we go plus 4x minus 8x minus 32. And then we factor by grouping. And then we factor out the common binomial factor, and we get that. Okay, when you start going through the factor pairs, you can do them in your head, multiply the number it adds, or you can start listing them all out. Eventually, when you get real fast at this, do it in our head, but for right now, you just write them all out. Let's see, let's try another one. Oh, sorry, another hint here. We know it adds to -4, the two pairs, which means the larger of the two numbers is going to be the negative one. So we don't even care about this. We don't care about this. We can skip these and just go to those three. Does that make sense? Okay. Um, okay. The product, it multiplies between positive 63 adds between negative 16. Where both numbers? Write down. There it is. Okay. And it doesn't matter the order of the two binomials. We can write x minus 9 times x minus 7. Same, just written in a different order. Why can we write it in a different order? Commutative property of multiplication. Oh, this is not a quadratic trinomial, it's a quadratic binomial. What term is it missing? So we got the quadratic term and the constant term. We're missing a linear. So what could I put in there if I want? Plus 0x. And now we're looking for factor pairs of negative 49 to add to be 0. And what numbers are those? 7 and negative 7. There we go. Okay, how is this polynomial different? The leading coefficient is not 1. Five is prime though. So what are our, it's not going to be x and x. What is it going to be? Yeah, one's going to be 5x, the other is going to be x. If it was 6x instead, there's a lot of possibilities. Okay. But here we're not looking for multiples of negative 12 that add to be 17. Let me do a quick example of multiplication. 2x plus 3 equals 5x plus 7. Okay, when we multiply these out, we get 10x squared plus 14x plus 15x plus 21. You can come get it tomorrow. Okay. But there are no factors. They multiply that out. Yeah, 21 added to 19. It's because these two numbers are affected by these coefficients here, the x. So we're going to do it a different method. You could guess and check, but here's how we're going to do it. Instead of just looking for factors of negative 12, we're going to multiply the 5 and the negative 12. 5 times negative 12, which is, what is that, negative 60? So we're going to look for factor pairs of negative 60 that add to be 17. Okay, these are significantly harder because we end up with much bigger numbers that we got to factor. So we multiply the leading coefficient and the constant term, and then we look for factor pairs of that. And this is positive, which means the larger of the two numbers is going to be positive. So 1, negative 1, 60, that doesn't work. 2 and 30, negative 3 and what, 15? 20? Okay. And sure enough, what does this add to be? It has to be 17. Okay. So this is when we're going to write 5x squared. We change the 17x to minus 3x plus 20x. And now we have 4 terms, and we factor by grouping. So all we did was change 17x to this. Uh, 20 and 12, what goes in there? 4. Okay. And so we get our x plus 4 times 5x minus 3. And there it is. Okay. So this is important. So when the leading coefficient is not 1, we multiply this, the leading coefficient, by the constant, then look for factor pairs of that number. Try this one on your own. And what's the pair that comes out to be? 5 and negative 8. Okay. That adds to be negative 3. And then finish it by factor by grouping. Okay, what questions do we have so far? Okay, let's try another one. Actually, um, this again is not a trinomial. What term are we missing? Constant term. We can write a plus zero. That's not going to help. We need two numbers that multiply to be zero. Okay. This one's way easier. We have a common factor. What's the common factor? X. You're done. Okay. So if it's a quadratic binomial it's missing the constant term, it just means it has a common factor we can factor out. Okay. Try this one. What is it? Oh gosh. What is it? 120? Thanks. Hello. I did 4 times 24. Okay. They both have to be negative. Why is that? They multiply to be positive, add to be negative. They both have to be negative. -2, -60, that's not it. -3, -40, 4. -30. I think that's it. Okay, what questions do we have on this?